Hello there, and welcome to this sleepy universe zone. Tonight, you are about to drift through one of the most extraordinary places in the cosmos, the Milky Way galaxy. Not just a faint streak across the night sky, but a colossal, living city of stars, gas, dust, and invisible forces. For the next few minutes, your imagination will float among spiraling arms, ancient stars, and mysterious dark matter, uncovering truths that will surprise, intrigue, and gently mesmerize you. Have you ever paused and wondered, what does it mean to live inside a galaxy? To orbit a star that is just one of hundreds of billions, spinning through a structure shaped by collisions and cosmic history. If you have, this journey is made for you. By the end, you will see the Milky Way in a way most humans never have, feeling both the vastness and your own quiet place within it. The Milky Way is not simply a collection of stars. It is a dynamic, evolving system, constantly reshaped over billions of years. Some stars drift calmly in the disk, while rare, rogue stars are flung outward at over 1 million kilometers per hour, escaping the galaxy entirely. Invisible dark matter weaves through it all, holding the galaxy together despite the immense centrifugal forces that should tear it apart. Without it, our home would not exist. Consider this: your solar system circles the galactic center at more than 828,000 kilometers per hour. Yet a single orbit, one galactic year, takes over 225 million Earth years. Even at this incredible speed, you and your world are still newcomers on a galactic scale. Ancient stars, older than the galaxy itself, float high above the disk, silent witnesses to events that unfolded billions of years before the sun ignited. Every cloud of gas, every spiral arm, every stellar cluster carries a story. Gas streams fall inward from the cosmic web, fueling new stars. Stellar nurseries glow with newborn suns, while supernovae scatter heavy elements that will someday form planets, and perhaps life. The very atoms in your body were forged in these processes, recycled over eons, linking you directly to the life of the galaxy. This content is for you, for anyone who has ever looked up at the night sky and felt both awe and curiosity. If you find calm in exploring the universe, consider liking this video. It helps others find this peaceful corner of the cosmos where learning and relaxation flow together. Tonight, as you listen, imagine the galaxy turning quietly around you. Stars orbit, gas drifts, and dark matter holds the invisible scaffolding of it all. The Milky Way is alive with motion, history, and secrets. You are not just a visitor here. You are part of the unfolding story, a small warmth floating in the spiral arms of a galaxy that has been growing, changing, and dreaming for over 13 billion years. Have you ever wondered why the Milky Way glows so beautifully across the night sky? That soft, hazy river of light is not random. It's the shimmering outline of the galaxy's spiral arms, massive highways of stars, gas, and dust, slowly rotating around the galactic center. Tonight, we will drift along these arms, discovering the places where stars are born, where cosmic history is written in light, and where the galaxy quietly reshapes itself. The Milky Way's spiral arms are not solid, permanent structures. Instead, they are density waves, rippling through the galactic disk like gentle traffic jams of stars and gas. As material moves through these waves, clouds of hydrogen and dust are compressed, triggering bursts of star formation. Stellar nurseries, glowing in radiant blues and silvers, emerge from these clouds, chaotic, luminous, and alive. Some of these nurseries are hundreds of light years across, cradling thousands of new stars at once. Imagine drifting slowly through one of these regions. The clouds are cold and dense, almost invisible in optical light, but inside, gravity gathers material, spinning and collapsing into protostars. Over millions of years, these clumps ignite nuclear fusion, and a new generation of stars awakens. Each star is unique, carrying chemical fingerprints of the gas it was born from: hydrogen, helium, and traces of heavier elements forged in the hearts of previous generations. These are the living chronicles of the galaxy, stories written in light and matter. Not all stars form quietly in isolation. Many are born in clusters, tightly bound groups emerging from the same cloud. Over time, gravitational forces tug at these clusters, scattering stars across the galactic disk. Even our Sun was likely born in such a stellar cluster. Its siblings now spread across the Milky Way, invisible companions tracing slow orbits far from their birthplace. The spiral arms also guide the motions of stars, influencing their orbits and even the pace of galactic evolution. Stars closer to the center move faster, while those on the outskirts drift more slowly, creating subtle patterns and twists that shape the arms themselves. Some stars occasionally drift into retrograde motion, a sign that they may have originated from smaller galaxies absorbed long ago. Within these arms, supernovae act as cosmic storms. Massive stars reach the end of their lives in cataclysmic explosions, scattering heavy elements into surrounding clouds. These elements, iron, calcium, gold, become the building blocks for future stars, planets, and even life itself. Every atom in your body may have once been part of this ongoing cycle of birth, death, and renewal. The Milky Way recycles its matter across billions of years, a quiet engine of creation hidden in plain sight. And yet, the spiral arms are only part of the story. Interstellar dust weaves through them, sometimes obscuring entire regions from view, yet providing the shielding and cooling necessary for stars to form. What seems like emptiness from afar is often a cradle for new light. Rogue stars occasionally wander through these arms, ejected from binaries or flung by the galaxy's central black hole, tracing glowing arcs through space like lonely travelers on endless journeys. As you drift with me now, imagine the gentle rotation of the galaxy, the subtle waves of the spiral arms carrying clouds, stars, and planets in a silent dance. The Milky Way is not static. It bends, stretches, and flows, alive with movement and energy. And somewhere within these spiraling highways, your solar system quietly rides along, a small passenger in a vast, luminous river of history and motion. Here, in the arms of the galaxy, the Milky Way writes its story, a story of creation, destruction, and endless transformation, quietly unfolding over billions of years. Every light you see, every shadow you imagine, carries a secret waiting to be discovered. Deep within the heart of the Milky Way lies a place that most eyes cannot see, a region cloaked in dust and mystery, the galactic core. Tonight, we venture inward, beyond the spiral arms, to explore the secrets that lie in this dense, luminous center, where ancient stars, a supermassive black hole, and the echoes of galactic history converge. The core of our galaxy is unlike any other region you've drifted through. Stars here orbit at breathtaking speeds, packed tightly in a crowded, glowing environment. Some of these stars are over 12 billion years old, older than the disk of the Milky Way itself. They float in elongated, tilted orbits, relics of smaller galaxies swallowed long ago. Every motion, every chemical fingerprint is a story of cosmic assimilation, silent testimony to collisions and mergers that shape the Milky Way. At the very center sits Sagittarius A star, the supermassive black hole, over 4 million times the mass of our Sun. Invisible to direct sight, yet profoundly felt, it orchestrates the motions of nearby stars, pulling them into tight, rapid orbits. Occasionally, gas clouds spiral inward, flaring with X-rays and high-energy radiation, a fleeting reminder of the black hole's immense power. This heart of gravity, though calm now, may have burned as a quasar billions of years ago, lighting up the galaxy from within. Surrounding Sagittarius, a star is a peanut-shaped bulge of stars, a structure sculpted by billions of years of motion. Seen from the side, it swells in the middle and narrows at the ends, like an hourglass of living stars. This shape is not just aesthetic. It reflects the gravitational rhythm of the galaxy, the slow, patient twisting and folding that occurs when billions of stars interact across time. Among these ancient residents are metal-poor stars, faint and quiet, with almost no elements heavier than helium. These stars formed shortly after the Big Bang, long before our Sun existed. They drift above and below the galactic plane in the halo, moving in ways that hint at their extragalactic origins. Their light is a window to a universe still young, chaotic, and forming its first structures. Even in the chaos of the core, there is creation. Stellar nurseries hide behind curtains of dust, forming new stars in pockets of glowing gas. Supernovae erupt periodically, sending shockwaves through the surrounding clouds, enriching them with iron, oxygen, and carbon, the essential elements for planets and life. The cycles of birth, death, and recycling continue here, quietly feeding the galaxy's evolution. Yet, not all motion is orderly. Rogue stars, flung from binary systems or ejected by the black hole's gravity, travel alone through the halo at incredible speeds. They are luminous reminders that even in a galaxy bound by gravity, moments of violent release occur, flinging light into the intergalactic void. As you drift with me now, imagine the core spinning gently, a dense ballet of stars, dust, and unseen forces. The Milky Way's heart is alive, a living archive of cosmic history, whispering stories of collisions, ancient stars, and gravitational mastery. Here, in the shadowed center, the galaxy's secrets are kept, waiting for patient observers to decode them. The core is not just a place of density. It is the memory of everything the Milky Way has consumed and the seed of what it will become. Every star, every orbit, every flare of radiation is a heartbeat in the galaxy's slow, eternal rhythm. A rhythm that you, in your quiet corner of the spiral arms, are part of tonight. Have you ever wondered why the Milky Way holds together at all? By all rights, the stars at its edges should fly outward, torn from the galaxy by centrifugal force. And yet, our galaxy spins gracefully, its spiral arms intact, stars following intricate orbits without scattering into the void. The secret lies in dark matter, an invisible substance that makes up most of the Milky Way's mass. Dark matter cannot be seen. nor does it emit or reflect light. It passes silently through stars, planets, and gas clouds, interacting only through gravity. Yet its presence is unmistakable. By measuring the motions of stars and the rotation of the galaxy, astronomers have determined that the visible matter, stars, gas, and dust, accounts for only a fraction of the Milky Way's total mass. The rest, hidden and mysterious, forms a vast halo enveloping the galaxy, binding it together. Imagine drifting through this halo. You cannot see it, yet it extends far beyond the spiral disk, encompassing ancient stars, globular clusters, and streams of shredded galaxies. Every stellar motion you observe, every orbit traced by Gaia's precise measurements, is influenced by this unseen scaffolding. Dark matter is a silent architect, holding the galaxy's structure and regulating the paths of stars across billions of years. Even within this invisible framework, the Milky Way is alive with motion. Gas flows inward from the cosmic web, drifting along the halo before feeding the disk and fueling star formation. Streams of stars from dwarf galaxies wrap around the spiral, remnants of collisions long past. Hypervelocity stars are flung outward, racing along the gravitational contours set by dark matter, their trajectories a vivid map of the galaxy's hidden mass. The halo also preserves fossils of the galaxy's formation. Globular clusters, dense spheres of hundreds of thousands of ancient stars, orbit quietly within the halo, some older than the Milky Way's disk itself. Their metal-poor compositions tell the story of a universe in its youth, before heavier elements were forged in the hearts of stars. Through them, we read the earliest chapters of cosmic history, written in light and motion. Dark matter does more than stabilize the Milky Way. It shapes its growth. As the galaxy accretes smaller satellites, the gravitational pull of dark matter ensures these mergers integrate smoothly, forming streams, shells, and ripples that trace the Milky Way's evolving structure. The galaxy is not static. It bends, warps, and twists, responding to the invisible currents that surround it, while billions of stars drift in quiet obedience to unseen forces. And yet, despite its mystery, dark matter connects you to the galaxy. Every orbit of your solar system, every rotation of the spiral arms, every gentle tug on distant stars is influenced by this invisible presence. Without it, the Milky Way would not exist as a coherent structure, and neither would the quiet, stable environment that allowed life to emerge on Earth. So as you settle into this moment, imagine the Milky Way, not just as stars and light, but as a vast, unseen framework, a gravitational web that cradles the galaxy in silence. It is a galaxy alive, dynamic, and carefully held together, with secrets hidden in the darkness that stretch far beyond what our eyes can perceive. Here, in this quiet scaffolding, the Milky Way spins, evolves, and persists, silently shaping the universe we call home. Beyond the glittering spiral arms and the dense core lies the Milky Way's halo, a vast, nearly invisible region that envelops the entire galaxy. Tonight, we drift into this outer domain where ancient stars, globular clusters, and remnants of long ago galactic mergers float quietly in the darkness, preserving the memory of the galaxy's earliest days. The halo is a spherical structure, far more diffuse than the disk, extending hundreds of thousands of light years from the galactic center. Within it reside stars that are metal poor, some formed shortly after the Big Bang, over 13 billion years ago. These are the elders of the galaxy, moving on tilted and elongated orbits, relics of smaller galaxies absorbed by the Milky Way during its slow, patient growth. Scattered across this halo are globular clusters, tightly bound spheres of hundreds of thousands of stars. They orbit the galactic center like silent moths circling a distant flame. Many are older than the disk itself, their stars lacking heavy elements, holding the chemical fingerprints of a universe still forming its first generations of stars. Observing them is like looking back through a cosmic time machine, a glimpse into the infancy of the Milky Way and the early cosmos beyond. The halo is also home to stellar streams, faint ribbons of stars pulled from disrupted dwarf galaxies. These ghostly trails wrap around the galaxy in delicate arcs and curves, evidence of collisions that occurred billions of years ago. Each stream tells a story of cosmic cannibalism, the quiet assimilation of smaller galaxies into a growing, evolving Milky Way. They are reminders that our galaxy is not static, but a living archive of motion, merger, and transformation. Even in this sparse outer region, movement continues. Stars trace slow, wide orbits, taking billions of years to complete a single revolution around the galactic center. Rogue stars and planetary wanderers pass through the halo, flung from their birthplaces or captured from smaller systems. They are luminous traces of forces we cannot see directly, traveling alone through the dark and vast spaces between spiral arms and core. Interstellar gas also reaches into the halo, part of the galactic fountain, a gentle cycle of material ejected from the disk by supernovae and stellar winds, cooling and falling back down over millions of years. This circulation stirs the halo, redistributes heavy elements, and sustains ongoing star formation in the inner galaxy. The halo is not empty. It is alive with slow motion, subtle interactions, and whispers of the Milky Way's history. As you float through this outermost region, imagine the galaxy as a layered structure, a bright disk, a dense core, and a faint, sprawling halo. Each layer is connected, yet each preserves a different epoch of cosmic evolution. The halo, quiet and ancient, cradles the memory of every collision, every formation event, and every star that ever wandered too far. In it, the Milky Way keeps its secrets, patiently preserving the story of billions of years in slow, graceful motion. Here, in this tranquil expanse, the galaxy feels immense yet intimate. It is a space of reflection, a cosmic archive that holds the past while shaping the future, inviting you to listen, drift, and connect with the ancient heart of the Milky Way. Not all stars follow the calm, predictable orbits we expect. Some are cast into extraordinary journeys, traveling alone at incredible speeds, far from the crowded disk or the spiral arms. These are the rogue stars and hypervelocity stars, cosmic wanderers flung across the galaxy by powerful forces. And tonight, we will follow their silent paths through the Milky Way. Hypervelocity stars are rare, yet awe-inspiring. Some are born from binary systems disrupted by the supermassive black hole at the galaxy's center. Imagine two stars orbiting each other in a tight embrace. One falls into the gravitational abyss of Sagittarius A star, vanishing into darkness, while the other is slingshot outward, propelled at over 1 million kilometers per hour. They traverse the halo and beyond, solitary travelers in a galaxy bound by gravity, yet free from its constraints. rogue stars can also result from violent supernova explosions. When a massive star detonates, its companion may be hurled into space, escaping the gravitational hold of its original system. These stars move in unpredictable trajectories, drifting far above or below the galactic plane, sometimes tracing arcs through the halo like glowing comets with no return. As we imagine their motion, picture the vast, silent dark of the halo. Here, light is sparse, distances immense, yet each rogue star carries the chemical signature of its origin. Some are enriched with heavy elements, born in dense, metal-rich regions, while others are metal-poor relics from the universe's earliest epochs. Every trajectory tells a story of past violence, of forces unseen, and of the galaxy's quiet ability to both hold and release its children. These travelers are not just curiosities, they are messengers. By studying their motion, astronomers uncover the hidden structure of the Milky Way's mass, including the distribution of dark matter that guides their paths. Each hypervelocity star is a probe, silently mapping regions we cannot see, tracing invisible scaffolds that govern the galaxy's motion. And yet, for all their speed, these stars move with a quiet elegance. They drift far from the crowded neighborhoods of stellar nurseries into empty regions where encounters are rare and time stretches differently. Their journeys are long, sometimes billions of years, crossing distances unimaginable, passing through the outer halo, and eventually escaping into intergalactic space. Imagine yourself floating alongside one of these stars, a solitary witness to the quiet dynamism of the Milky Way. The galaxy is not only a home, but also a crucible of movement, sending some stars outward while others remain bound in graceful, eternal orbits. In these rogue travelers, we see both the violence and the poetry of cosmic evolution, the galaxy releasing, reshaping, and continuing its slow, deliberate growth. Tonight, as you drift in your chair or your bed, picture the hypervelocity stars streaking silently through the darkness. They are the rare sparks of rebellion in a galaxy that otherwise hums in rhythm, showing us that even in immense gravitational order, there is room for chaos, freedom, and motion that defies expectation. The Milky Way is alive not just in the visible arms or the dense core, but in every solitary star racing across its unseen vastness. Beyond the spiral arms and beyond the glittering core lies another hidden structure, subtle yet powerful, the central bar of the Milky Way. Unlike the neat pinwheel diagrams often shown in textbooks, the heart of our galaxy is elongated, dynamic, and layered, shaping the motion of stars and gas for billions of years. Tonight, we drift closer to this dense, bar-shaped interior, discovering the forces that sculpt the galaxy from within. The bar is not a static feature. It rotates slowly, exerting gravitational influence that guides stars and gas inward toward the core. This slow pull can funnel material into the central regions, feeding Sagittarius A star and nurturing bursts of star formation in the surrounding bulge. Deep within this bar, astronomers have even found hints of a smaller inner bar, tilted at a different angle, rotating independently, a hidden mechanism that quietly regulates the galactic heart. Surrounding the bar is the peanut-shaped bulge, swelling in the middle and tapering at the ends. It is a three-dimensional structure, shaped over billions of years by the orbits of countless stars. Each stellar path adds a subtle rhythm to the overall shape, forming a twisting hourglass of light and gravity. It is both chaotic and orderly, a testament to the slow, patient sculpting of gravity acting across immense timescales. Within this central region, stars move in complex orbits. Some circle rapidly near the bar, while others drift in slower, elongated paths that weave above and below the galactic plane. Ancient stars from swallowed dwarf galaxies populate this area, carrying chemical signatures and motion patterns that tell the story of mergers long past. The Milky Way's history is written not only in light, but in motion, a celestial dance recorded in the paths of these stars. Gas clouds follow the gravitational currents, compressed as they pass through the bar, sparking waves of stellar birth. The central bar acts as both a conveyor and a catalyst, directing material inward while shaping the spiral arms outward. Supernovae from these newborn stars enrich the surrounding medium, seeding the galaxy with heavy elements, the very building blocks of planets, moons, and life. Imagine floating above this central region, the stars moving in tightly bound, overlapping orbits, the bar rotating gently beneath you. Invisible forces ripple through the stars, magnetic fields threading the disk, and the black hole at the core lies silently at the center, its gravitational presence felt in every orbit. This is the Milky Way's layered heart, complex, alive, and constantly shaping the galaxy we call home. Even as you rest, the central bar continues its slow revolution, a reminder that the galaxy is not static. Its heart is intricate, full of hidden mechanisms and quiet motion, governing the destiny of stars, gas, and planets alike. In the stillness of the night, imagine the Milky Way's heart turning patiently, a layered, living structure, sculpting the galaxy from the inside out, one orbit at a time. Now, let us drift from the galaxy's dense heart to its luminous spiral arms, where life begins in the form of stellar nurseries. These are the cradles of stars, vast clouds of hydrogen and dust, glowing softly with the promise of creation. Tonight, we explore the quiet, intricate processes that birth new suns and shape the Milky Way's radiant arms. Stellar nurseries are immense, sometimes hundreds of light years across, hidden behind thick veils of interstellar dust. From afar, they may appear as dark patches against the glowing backdrop of the galaxy. But within these clouds, gravity gathers material into dense clumps. Over millions of years, these clumps collapse, heating and spinning until nuclear fusion ignites and a new star awakens. Each of these newborn stars carries the chemical legacy of its parent cloud, including traces of elements forged in previous generations of stars. Not all stars are born alone. Many emerge in clusters, hundreds or even thousands of siblings bound together by gravity. These clusters drift slowly through the spiral arms, sometimes breaking apart over time, scattering their stars across the disk. Even our sun likely began life in such a cluster, now dispersed into the vast stellar sea of the Milky Way. Within these nurseries, motion is constant yet subtle. Gas clouds compress, shock waves ripple outward from nearby supernovae, and magnetic fields guide the collapse of material. Each new star formation event enriches the surrounding space with elements like iron, carbon, and oxygen, building blocks that will someday form planets, moons, and potentially life. Every atom in your body may once have been part of such a stellar cradle, recycled over billions of years through countless cycles of creation and destruction. Some stellar nurseries glow with visible light, their young stars radiating ultraviolet energy that illuminates surrounding gas in brilliant blues and silvers. Others remain hidden, visible only in infrared, where the warmth of forming stars pierces through cold, opaque clouds. Together, these nurseries form the glowing skeleton of the spiral arms, shaping the luminous patterns we observe from Earth. Even in the quiet of the galaxy, chaos plays a role. Supernovae erupt, compressing nearby clouds and triggering new waves of star formation. Rogue stars pass through these regions, disturbing orbits and seeding complexity. Yet out of this controlled turbulence emerges order, a spiral galaxy glowing with young stars, shaped by cycles of birth, death, and rebirth. As you drift in this moment, imagine the spiral arms stretching outward, cradling countless stellar nurseries. Picture each cloud collapsing slowly, each star igniting in silence, and the Milky Way humming softly with creation. This is not just a galaxy. It is a living, breathing ecosystem where the past and future of stars, planets, and life itself unfold gently, patiently, in the vast cosmic night. As we continue drifting through the Milky Way, we encounter one of the galaxy's most dramatic forces, supernovae, the explosive deaths of massive stars. These stellar cataclysms are not mere destruction. They are the engines of creation, scattering the elements forged in stars across space and setting the stage for new generations of suns and planets. Tonight, we witness the galaxy's ability to recycle itself, quietly yet relentlessly, over billions of years. A supernova begins when a massive star exhausts its nuclear fuel. Without the outward pressure of fusion to counterbalance gravity, the core collapses, triggering an explosion so powerful it can briefly outshine an entire galaxy. Shockwaves ripple outward, compressing nearby gas clouds and stirring the interstellar medium. These shockwaves often trigger star formation, igniting new stellar nurseries from the remnants of older stars. The material expelled in a supernova is rich in heavy elements: iron, calcium, oxygen, and carbon, essential ingredients for planets and life. Every atom in your body, every grain of sand on Earth was once part of this cosmic recycling process. In this way, the Milky Way breathes. Stars live, die, and return their material to the galactic ecosystem, perpetuating the cycle of creation. Supernovae also shape the structure of the galaxy. They carve cavities in the interstellar medium, forming bubbles and chimneys that vent hot gas into the halo. This circulation redistributes material, spreads heavy elements across vast distances, and influences the next generation of star formation. Even in the quiet night sky, these explosions have left subtle imprints, sculpting the patterns we observe in the spiral arms and the halo. Some supernovae leave behind neutron stars or pulsars, compact remnants spinning hundreds of times per second, emitting beams of radiation that sweep across space like cosmic lighthouses. These pulsars act as precise clocks, tracing the galaxy's structure, mapping magnetic fields, and sometimes revealing hidden phenomena such as gravitational waves. Each pulsar is a marker of a past cataclysm, silently recording the galaxy's history in regular pulses of light. The Milky Way's supernovae remind us that the galaxy is never static. Even in the calm glow of the spiral arms, violent forces shape the evolution of stars, gas, and dust. They demonstrate the delicate balance between destruction and creation, showing how chaos and order intertwine in the rhythm of cosmic life. As you float in this quiet moment, imagine the supernova lighting up distant regions, their energy rippling through clouds and nebulae. Picture the elements scattered across light years, drifting slowly into new clouds, ready to ignite the next generation of stars. The Milky Way is not just a collection of shining points. It is a living, breathing cycle of matter, energy, and time, recycling itself endlessly, quietly crafting the story of the universe you are part of tonight. As we drift further through the Milky Way, we encounter a subtle yet essential component of the galaxy: interstellar dust. Tiny grains of carbon, silicates, and ice float between the stars, almost invisible to the naked eye. Yet they play a crucial role in shaping the light we see, guiding star formation, and even carrying the ingredients for life. Tonight, we explore the hidden beauty of this cosmic dust and the quiet influence it exerts across our galaxy. Interstellar dust may seem like mere debris, but it is far from inert. Dust clouds absorb and scatter visible light, obscuring distant stars and nebulae. What looks like darkness from afar is often a cradle for new stars, shielding dense molecular clouds from harsh radiation and allowing gravity to gather material quietly. Without this dust, many stellar nurseries would never collapse into new stars, and the galaxy's spiral arms would lose their luminous patterns. These tiny particles also interact with the galactic magnetic field, aligning along invisible lines of force and subtly influencing the motion of gas and charged particles. Some dust grains spin rapidly, emitting faint microwave light, while others polarize starlight passing through them, allowing astronomers to map magnetic structures across vast distances. Dust is, in essence, both painter and guide, shaping the Milky Way's unseen framework. Beyond influencing stars and gas, interstellar dust is rich in organic molecules. Complex carbon-based compounds, including polycyclic aromatic hydrocarbons, simple sugars, and alcohols, float through these clouds. These ingredients, carried across light years by galactic winds, may seed forming planetary systems with the raw materials for life. Some may have even fallen onto the early Earth, connecting the galaxy's vastness to the emergence of life on our planet. Dust also participates in the galaxy's recycling system. When stars die in supernova, dust absorbs energy, cools surrounding gas, and helps regulate the collapse of new clouds. It drifts along spiral arms, merges with clouds, and contributes to the formation of planets and planetary systems. Without this quiet, persistent presence, the Milky Way would be far less structured, and the cycle of star birth and death would be disrupted. As you imagine floating through the dust-filled arms of the Milky Way, picture the faint glow of scattered starlight, the invisible threads of magnetic fields, and the tiny grains carrying molecules that may one day spark life elsewhere. The galaxy's beauty is not only in its bright stars or swirling spirals, but in these hidden, delicate structures, quiet architects of cosmic creation, shaping the Milky Way in ways that are invisible, yet profoundly essential. Tonight, as you rest, let yourself drift among these silent clouds, feeling the hidden rhythm of the galaxy. Dust may be small, nearly unseen, but it is mighty in its influence, a gentle, persistent force sculpting the Milky Way, quietly sustaining its brilliance and nurturing the next generation of stars and worlds. Beyond the bright stars and luminous nurseries, the Milky Way contains vast starless clouds, dark regions of gas and dust that have yet to ignite into light. These massive clouds drift silently through the galaxy, holding the potential for future stars and perhaps entire planetary systems. Tonight, we explore these quiet possibilities where the galaxy seems to pause, holding its breath before creation begins. Starless clouds are composed mostly of molecular hydrogen, sometimes stretching hundreds of light years across. They are cold, dark, and diffuse, often appearing invisible even to powerful telescopes. Yet within these clouds, gravity and turbulence slowly gather material into denser regions, preparing the seeds of future stars. Some clouds may never collapse, drifting indefinitely until disrupted by external forces, like passing shock waves or collisions with other clouds. Even in their dormancy, these clouds are part of the Milky Way's cosmic engine. They act as reservoirs, storing raw material for star formation that may occur millions of years from now. Over cosmic timescales, the gas within these clouds is recycled repeatedly, passing through generations of stars and supernovae, each cycle enriching the material with heavier elements. This slow, quiet preparation ensures the galaxy's continuity, even in regions that appear empty. Occasionally, external disturbances awaken these clouds. Supernova shock waves, spiral arm density waves, or gravitational tugs from nearby stars can compress the gas, triggering collapse and initiating the birth of new stars. What seems like a void becomes a cradle, hidden from view, where the next generation of luminous stars will emerge. Even the darkest regions of the galaxy are alive with potential, waiting for the right moment to ignite. Starless clouds also illustrate the dynamic complexity of the Milky Way. Not all matter moves in predictable orbits. Some clouds follow tilted orbits, some drift through the halo, and others hover near the disk. Their paths record past interactions, mergers, and gravitational influences, preserving the history of the galaxy in a way that is invisible yet measurable. As you drift alongside these silent clouds, imagine the quiet potential they hold. They are dark, mysterious, and almost invisible, yet they carry the promise of creation, the raw materials for stars, planets, and possibly life itself. The Milky Way is not only a galaxy of bright lights and swirling spirals. It is a living system of hidden possibilities, where even emptiness is pregnant with the next chapter of cosmic history. Tonight, in the stillness of your mind, let yourself float among these clouds. They remind us that the galaxy is patient, that creation can occur in silence, and that the Milky Way, in its vastness, holds countless secrets waiting for the right spark to awaken. Far above and below the spiral disk of the Milky Way, a gentle cycle unfolds, the galactic fountain. This is the galaxy's way of breathing, quietly circulating gas and dust between the dense plane of stars and the vast, nearly invisible halo. Tonight, we drift through this motion, witnessing how the Milky Way sustains itself and nurtures the birth of new stars over billions of years. The galactic fountain begins with stellar winds and supernovae in the disk. When massive stars reach the end of their lives, they explode violently, ejecting hot gas and dust into space. This material rises into the halo, sometimes thousands of light years above the plane, forming immense, diffuse clouds that slowly cool and condense. Over millions of years, gravity draws this material back down toward the disk, replenishing the interstellar medium and fueling new generations of stars. This cycle is both quiet and relentless. Unlike the dramatic flashes of supernovae, the fountain moves gradually, almost imperceptibly, a slow rhythm connecting the galaxy's inner regions to its outer halo. It redistributes heavy elements, including carbon, oxygen, and iron, seeding the disk with the building blocks necessary for planets and life. Every atom in your body may have once traveled through this cosmic fountain, drifting silently from star to cloud to star again. The fountain also shapes the structure of the Milky Way. As gas moves through the halo, it interacts with magnetic fields and existing clouds, stirring turbulence that influences star formation. Over billions of years, these flows contribute to the warps, ripples, and subtle asymmetries of the galactic disk. Even when the galaxy appears calm from Earth, it is alive with motion, quietly sculpted by unseen currents. Some gas streams rise at odd angles, tilted from the disk, tracing paths that reveal past mergers with dwarf galaxies or interactions with dark matter. Others fall back along the plane, compressing clouds and igniting bursts of star formation. In this way, the galactic fountain connects the inner and outer Milky Way, uniting regions separated by tens of thousands of light years. As you drift through this vast, unseen motion, imagine the Milky Way breathing around you. Gas rises, cools, and falls in a continuous loop, enriching the galaxy and sustaining its life cycle. The fountain is subtle, invisible to the naked eye, yet it is essential, a quiet engine driving the galaxy's renewal. Tonight, let yourself feel this rhythm. The Milky Way is not merely a collection of stars, it is a living system, circulating, evolving, and regenerating across eons. In its silent breaths, the galaxy carries the history of creation and the promise of countless stars yet to be born, and you, floating quietly within it, are part of this endless cosmic cycle. Beyond stars and clouds, the Milky Way is also home to countless planetary systems, each orbiting its own star, unique in composition, size, and structure. Tonight, we drift among these systems, discovering the diversity of worlds, the processes that shape them, and the subtle ways the galaxy influences their formation and motion. Planets are a natural consequence of star formation. As a new star ignites within a collapsing cloud of gas and dust, a rotating disk forms around it. Within this disk, particles collide, stick together, and gradually grow into planets, moons, and smaller bodies. Across the Milky Way, these systems vary widely. Some host massive gas giants with icy moons. Others contain compact arrangements of rocky planets hugging closely to dim stars. The variety is astounding, reflecting the galaxy's intricate chemical and gravitational environment. Even the position of a planetary system within the galaxy matters. Some regions, near the core or in dense spiral arms, are exposed to frequent supernovae and intense radiation. Others, like our solar system in the Orion Spur, occupy calmer zones where life might have time to emerge. These galactic neighborhoods shape the stability, composition, and potential habitability of worlds, linking the fate of planets to the larger motions of the Milky Way itself. Planetary systems are not fixed. Over time, stars and their planets drift through the disk, occasionally influenced by spiral arm density waves or gravitational interactions with nearby stars. Some planets are even ejected entirely, becoming rogue worlds, drifting alone through the halo or intergalactic space. These orphan planets are silent wanderers, unseen yet abundant, carrying the memory of their original systems as they traverse the galaxy. Chemical diversity within planetary systems also mirrors the Milky Way's evolution. Stars rich in heavy elements tend to host more rocky planets, while metal-poor stars may have smaller, less complex planetary systems. Every planet, every asteroid, and every comet carries a story of past stellar generations, a legacy of cosmic recycling that spans billions of years. As you imagine drifting past these distant worlds, picture the immense variety of planetary systems, from tightly packed rocky orbits to wide swaths of frozen gas giants. Imagine rogue planets gliding silently through the halo, and young systems forming in glowing nebulae, each contributing to the galaxy's ongoing evolution. Tonight, the Milky Way is more than stars and dust. It is a vast, interconnected network of planetary systems, each orbiting its star, each influenced by the galaxy's gravity, its spiral arms, and its history. Floating among them, you are part of a galaxy teeming not just with light, but with the potential for life, diversity, and discovery, a silent witness to the endless variety of worlds spinning through the cosmic night. Tonight, we drift closer to home, to the quiet lane of stars where your solar system resides, a small structure within the Milky Way known as the Orion Spur. Unlike the grand spiral arms that dominate the galaxy's disk, the Orion Spur is a minor branch, a calm, relatively sparse corridor of stars nestled between the larger Sagittarius and Perseus arms. Here, life had the time and stability to emerge, and tonight we explore why this region matters. The Orion Spur is not remarkable for its brightness or density, but for its serenity. Massive supernovae are rarer here, and radiation storms less frequent than in the galaxy's bustling inner arms. This relative safety may have given Earth the quiet conditions needed for life to develop, allowing complexity to unfold over billions of years. Every orbit of the Sun in this region carries your planet farther from the chaos of denser, more turbulent neighborhoods. Our solar system orbits the galactic center at an average speed of over 828,000 kilometers per hour. Yet it is not moving in a straight line. It bobs gently above and below the galactic plane, rising and falling over tens of millions of years in a slow, wave-like motion. This vertical oscillation, subtle yet persistent, is influenced by the Milky Way's gravity and the distribution of dark matter. Some scientists speculate it may even contribute to long-term cycles on Earth, though the evidence remains inconclusive. Within the Orion Spur, stars move in harmony with the spiral arm patterns, but not perfectly. The Sun orbits near the co-rotation radius, a special distance where the spiral arm's rotation matches the average motion of stars. This gentle alignment may reduce the frequency of spiral arm crossings, shielding the solar system from excessive gravitational disturbances and supernova hazards. In this quiet neighborhood, planets can stabilize and life can flourish. The interstellar medium here is alive yet calm. Gas clouds drift slowly through the spur, some forming new stars and planets, others remaining dormant, like potential waiting to be awakened. Dust grains rich in organic compounds float silently, carrying the building blocks of life across light years, some eventually settling onto planets, including Earth itself. As you drift in this quiet lane, imagine the Sun and its planets moving gently through a calm pocket of the galaxy. Stars nearby are friends and distant neighbors, their motions slow and predictable. Rogue stars or rare supernovae may pass by, but the overall rhythm of the Orion Spur is one of stability and quiet order. Tonight, the Orion Spur reminds us that not all of the Milky Way is chaotic. Some regions are calm, serene, and nurturing, providing the perfect environment for stars, planets, and life to evolve. Floating within it, you are part of a quiet cosmic corridor, a passenger in a galaxy alive with motion, yet remarkably gentle in this corner of its vast spiral. Now, let us follow the Sun's journey around the center of the Milky Way, a vast orbit that defines a unit of time almost unimaginable: the galactic year. Tonight, we drift alongside our star, tracing its path through the galaxy, and discover how this immense motion connects us to the broader story of the Milky Way. The Sun orbits the galactic center at an average speed of more than 828,000 kilometers per hour. At first glance, that seems impossibly fast, yet the Milky Way is so enormous that one complete orbit takes approximately 225 to 250 million Earth years. In all its 4.6 billion year history, the Sun has completed fewer than 20 such orbits. The last time it passed through this region, the supercontinent Pangaea was just beginning to break apart, and dinosaurs had not yet emerged. This slow, sweeping motion places our solar system in a dynamic context. As the Sun travels through the spiral arms, it moves in and out of regions of higher star density, encounters molecular clouds, and is gently influenced by the Milky Way's gravity. Occasionally, these motions may disturb comets or trigger subtle shifts in the interstellar medium, reminding us that even on cosmic scales, motion matters. The galactic year also connects us to the broader rhythms of the galaxy. Stars nearer the center orbit faster, while those on the outskirts move more slowly. This difference in speed helps maintain the spiral arms, creating density waves that compress gas and trigger new star formation. The Sun's orbit is carefully aligned with these patterns, providing a relatively stable environment for the solar system. Yet, the journey is not flat. The Sun bobs above and below the galactic plane in a gentle wave, rising and falling over tens of millions of years. This oscillation, subtle and imperceptible on human timescales, is a reminder that the galaxy is alive with motion, a complex interplay of gravity, mass, and the unseen influence of dark matter. As you imagine drifting alongside the Sun, picture the vastness of its orbit, the hundreds of millions of years it takes to complete a single loop, and the countless stars, gas clouds, and nebulae it passes. The Milky Way is not static. It flows, rotates, and evolves, carrying our solar system within it, connecting Earth to the galaxy's rhythm in ways both profound and unseen. Tonight, the galactic year reminds us that time is relative. What seems slow to us is vast on a cosmic scale. Floating with the Sun, we feel the immense sweep of motion, the gentle rhythm of the Milky Way, and the deep connection between our planet, our star, and the galaxy we call home. Tonight, we turn our attention to the rotation of the Milky Way, the subtle forces that shape its spiral arms, and the invisible patterns that orchestrate the movement of billions of stars. Unlike planets orbiting a single star in predictable paths, stars in the galaxy move with more freedom, influenced by gravity, dark matter, and density waves, creating the elegant spirals we see from Earth. In the inner regions of the galaxy, stars orbit rapidly around the galactic center, completing loops in a few million years. Farther out, stars move more slowly, yet the difference is not enough to tear the spiral arms apart. This apparent contradiction puzzled astronomers for decades until the presence of dark matter was confirmed. Invisible and pervasive, dark matter forms a halo around the Milky Way, providing the gravitational scaffolding that keeps stars bound and maintains the galaxy's structure. The spiral arms themselves are not solid structures. They are patterns of higher density regions, moving like slow traffic jams through the galactic disk. As stars and gas pass through these waves, molecular clouds are compressed, triggering star formation. Bright young stars illuminate the arms, creating the glowing ribbons visible across the night sky. As they age, these stars drift out of the arms, replaced by new generations of light, giving the spirals a dynamic, ever-changing appearance. Within these arms, molecular clouds and stellar nurseries form and collapse, creating clusters of new stars. Over time, gravitational interactions scatter some of these stars across the disk. Even our Sun drifts through these patterns, moving in and out of the spiral density waves over millions of years, carried gently along by the Milky Way's rotation. Stars also exhibit irregular motions. Some orbit backward in the outer halo, a signature of past galactic mergers, while rogue stars and hypervelocity stars traverse extreme paths, tracing the invisible contours of dark matter and the galaxy's gravitational forces. These motions reveal the hidden architecture of the Milky Way, a complex web of mass and motion beyond what our eyes can see. As you drift alongside the galaxy, imagine the spiral arms flowing past you, clouds of gas compressed and lit by newborn stars, and the silent pull of dark matter guiding every orbit. The Milky Way is not a static clockwork. It is a living, breathing structure, constantly reshaped by motion, gravity, and the quiet rhythms of cosmic time. Tonight, the galaxy's rotation reminds us that even in apparent stillness, motion governs every part of the Milky Way. Stars swirl, arms ripple, and unseen forces guide the dance of light and matter, creating the vast, intricate patterns that cradle our solar system and all that we call home. Drifting deeper into the Milky Way, we encounter its molecular clouds, the vast, cold reservoirs of gas and dust where stars are born. These clouds are the hidden wombs of the galaxy, often hundreds of light years across, invisible in ordinary light, yet teeming with the potential to ignite new suns. Tonight, we explore these immense, shadowy regions and the quiet processes that give rise to stellar life. Molecular clouds are primarily composed of hydrogen molecules, with traces of helium and heavier elements. Their temperatures are just a few degrees above absolute zero, making them some of the coldest objects in the galaxy. Within these frigid expanses, gravity slowly gathers material into dense clumps. Over millions of years, these clumps collapse under their own weight, forming protostars that will eventually ignite in nuclear fusion. Not all molecular clouds form stars. Some drift silently through the galaxy, too diffuse or stabilized by internal turbulence to collapse. These clouds are potential energy waiting in the dark, reservoirs of gas that may one day give birth to stars or be dispersed by external forces. Even in their dormancy, they shape the galaxy, influencing the motion of nearby stars and guiding the flow of interstellar material. The most active clouds are stellar nurseries, glowing with the birth of hundreds or thousands of young stars. Their ultraviolet radiation illuminates surrounding gas, creating stunning regions of light and shadow. Some clouds are sculpted by shockwaves from nearby supernovae, compressed into filaments and clumps that will collapse into new stars. In these processes, chaos and order coexist, and creation emerges from the quiet interplay of forces. Molecular clouds also contribute to the galaxy's chemical enrichment. As stars form and die, they recycle material into these clouds, adding heavy elements like iron, carbon, and oxygen. Over billions of years, this cyclical process gradually builds the complex chemistry necessary for planets and life. Each cloud carries the history of the Milky Way in its composition, a living archive of stellar generations. Imagine drifting through these dense, cold regions, the darkness pierced only by the faint glow of forming stars. The clouds ripple and swirl under gravity, magnetic fields, and turbulence, a quiet ballet of matter waiting to ignite. They are the Milky Way's wombs, where the next generation of stars and planetary systems will emerge. Tonight, as you float among these clouds, remember that creation often begins in silence. The galaxy breathes through these molecular giants, patiently assembling the raw materials for light, life, and cosmic evolution. In their shadowed depths lies the quiet promise of the Milky Way's future. Beyond the calm of molecular clouds, the Milky Way occasionally stirs violently. Supernova explosions erupt, sending shockwaves rippling through space, reshaping gas clouds, triggering star formation, and spreading heavy elements across vast distances. Tonight, we drift through these cosmic storms, witnessing the galaxy's most dramatic processes in quiet contemplation. A supernova occurs when a massive star exhausts its nuclear fuel. Without outward pressure from fusion, the core collapses, creating an explosion that can briefly outshine billions of stars. These shockwaves sweep through the surrounding interstellar medium, compressing molecular clouds and sometimes igniting new waves of star formation. In this way, destruction becomes creation. The death of one star lays the foundation for countless new ones. The material expelled in a supernova is rich in heavy elements like iron, calcium, carbon, and oxygen. These elements disperse through gas clouds, seeding future generations of stars, planets, and potentially life itself. Every atom in our bodies may once have been part of such a cosmic explosion, recycled over billions of years in a grand cycle of galactic renewal. Supernovae also shape the structure of the Milky Way. They carve enormous cavities, forming bubbles and chimneys that channel hot gas into the halo. This circulation redistributes elements, stirs the interstellar medium, and influences star formation far beyond the initial explosion. Even the seemingly calm regions of the galaxy bear the subtle signatures of these violent events. Some supernovae leave behind neutron stars and pulsars, compact remnants spinning hundreds of times per second. Pulsars emit beams of radiation, sweeping across the galaxy like silent lighthouses. Their pulses help astronomers measure distances, map magnetic fields, and even detect gravitational waves. Each is a quiet record of past cataclysms, a celestial heartbeat marking the life and death of stars. As you drift through this dynamic environment, imagine shockwaves spreading through clouds, compressing gas, and sparking the birth of new stars. Picture the elements forged in dying stars mixing into the galaxy, slowly forming the next generation of suns and planets. The Milky Way thrives not despite these explosions, but because of them, a galaxy where chaos and creation are intertwined in perfect, patient balance. Tonight, let yourself float through these cosmic storms. Even in violence, there is beauty. The galaxy recycles itself with every shockwave, every flare, and every pulse, quietly sculpting its spiral arms, nurturing new stars, and writing the ongoing story of creation that you are part of. Tonight, we drift through the galactic disk, the broad, luminous plane of the Milky Way, where most of its stars reside. Unlike a single flat sheet, the disk is layered, textured, and alive, shaped by billions of years of motion, collisions, and subtle gravitational forces. In this quiet journey, we explore its thin and thick components, discovering how the galaxy's structure preserves its history while nurturing new stars. The thin disk is where we live. It is wide and dense, filled with young stars, open clusters, and gas clouds actively forming new suns. The spiral arms wind through this layer, guiding the motion of stars and molecular clouds. Within the thin disk, star formation is ongoing, and elements forged in past generations enrich new stars and planets, creating the foundation for complex chemistry and life itself. Above and below the thin disk lies the thick disk, older, puffier, and more diffuse. Stars here are ancient, metal-poor, and follow tilted elliptical orbits. Many formed in the early phases of the galaxy, before the thin disk fully developed. These stars are relics of the Milky Way's formative years, preserving the record of mergers, accretions, and gravitational interactions that built the galaxy over billions of years. The disk is far from uniform. It warps and ripples, bending upward on one side and downward on the other. These distortions may result from gravitational tugs by satellite galaxies, clumps of dark matter, or past mergers, revealing that even the seemingly calm plane of stars is responsive to forces both seen and unseen. This subtle undulation gives the galaxy its character, a gentle, living rhythm woven into its structure. Gas, dust, and magnetic fields thread through the disk, interacting with stars and shaping their formation. Molecular clouds drift through spiral arms, compressed by density waves, igniting new stellar nurseries. Interstellar dust absorbs and scatters light, creating regions of darkness where stars can quietly emerge. Even in apparent stillness, the disk is a dynamic, breathing system, cycling matter, energy, and information through the galaxy. As you drift gently above the disk, imagine layers of stars moving at different speeds, ancient orbits twisting in silent complexity. Feel the subtle warp, the unseen currents of gas and magnetic fields, and the quiet yet constant formation of stars. The Milky Way's disk is not just a stage for stars. It is a living archive, preserving the past, sustaining the present, and shaping the future of the galaxy. Tonight, let yourself float within this layered plane, a passenger in a galaxy that is both ordered and dynamic, textured and alive. The disk holds countless stories in every orbit, every ripple, every hidden cloud, a vast, luminous tapestry of cosmic motion that you are quietly part of. Drifting further through the Milky Way, we encounter a hidden yet powerful influence, the galactic magnetic field. Though invisible to the eye, this subtle force threads through the disk and halo, shaping the motion of gas, dust, and charged particles. Tonight, we explore how the Milky Way's magnetic field breathes life into the galaxy, guiding its hidden rhythms. The magnetic field stretches across thousands of light years, rising into the halo and intertwining with spiral arms. It is weak by earthly standards, yet over cosmic distances, it profoundly affects the interstellar medium. Gas clouds align along magnetic lines, dust grains spin or polarize starlight, and cosmic rays follow invisible currents shaped by the field. In essence, the Milky Way hums with magnetism, a subtle pulse beneath the brilliance of its stars. This field influences star formation. Molecular clouds are guided and stabilized by magnetic forces, which can delay or accelerate collapse. Regions of high magnetic tension can slow the birth of stars, while weaker zones allow clouds to condense more freely. Over billions of years, the interplay of gravity and magnetism has sculpted the spiral arms and regulated the flow of gas throughout the galaxy. The magnetic field also interacts with cosmic rays, high-energy particles born in supernovae and distant galaxies. These particles spiral along field lines, colliding with gas clouds, stirring turbulence, and occasionally impacting planetary atmospheres. Though invisible and imperceptible to humans, this interaction subtly shapes the environment within the Milky Way, influencing both stars and planetary systems. Even interstellar dust dances to this magnetic rhythm. Grains align with the field, creating patterns in polarized starlight that allow astronomers to map the otherwise unseen structure of the galaxy. Through these faint signals, we perceive the galaxy's hidden architecture, revealing forces that guide motion and structure across tens of thousands of light years. As you drift silently, imagine these invisible threads stretching across the Milky Way, linking stars, clouds, and cosmic rays in a quiet network of unseen forces. The galaxy is alive not just in its light and motion, but in this subtle, pervasive field, a gentle influence that shapes creation, guides matter, and sustains the Milky Way's enduring rhythm. Tonight, the magnetic field reminds us that the galaxy is more than what we see. It is a living system of invisible currents, where forces beyond sight orchestrate motion, influence creation, and quietly hold together the luminous spiral of stars we call home. Beyond stars, dust, and magnetic fields, the Milky Way is filled with the interstellar medium, a thin, complex mixture of gas, plasma, and dust that weaves through the galaxy like a hidden, dynamic web. Tonight, we drift through this invisible fabric, discovering how it sustains stars, shapes nebulae, and connects the galaxy in ways that remain mostly unseen. The interstellar medium may appear empty, but it is far from lifeless. Gas and plasma swirl in filaments, bubbles, and shockwaves, stirred by stellar winds, supernovae, and the galaxy's gravitational forces. Temperatures range from a few degrees above absolute zero in molecular clouds to millions of degrees in hot bubbles formed by exploding stars. Each region carries a distinct history, a record of past stellar births, deaths, and migrations. Within this medium, molecular clouds collapse to form new stars, while expanding cavities from supernovae carve space and redistribute elements. Dust grains absorb energy, cool surrounding gas, and facilitate the next generation of star formation. Even areas that seem dark or empty from Earth are teeming with motion, turbulence, and potential, quietly shaping the Milky Way over millions of years. The interstellar medium also acts as a conduit for cosmic rays and high-energy particles. These particles, moving near the speed of light, collide with atoms in gas clouds, generating showers of secondary particles and influencing the chemistry of the medium. In this way, even the invisible components of the galaxy interact, transporting energy and information across vast distances. Magnetic fields thread through the medium, guiding charged particles and shaping cloud structures. The result is a delicate balance between gravity, pressure, magnetism, and turbulence. Over billions of years, this invisible fabric has sculpted the spiral arms, influenced star formation, and even protected some regions from excessive disturbances, creating pockets where life-bearing planets could eventually arise. As you drift through this hidden network, imagine vast clouds of gas and dust weaving silently between stars, pulsars sending beams of radiation, and magnetic fields guiding the flow of cosmic energy. This is the Milky Way's quiet backbone, a living, breathing medium that connects stars, nebulae, and planetary systems in a continuous, invisible web. Tonight, the interstellar medium reminds us that the galaxy's life is not only in light or visible motion. It thrives in the unseen currents and subtle structures that govern matter, nurture creation, and sustain the Milky Way's quiet, intricate dance across billions of years. As we continue drifting through the Milky Way, we encounter a subtle yet constant presence: cosmic rays. These high-energy particles, mostly protons and atomic nuclei, stream through the galaxy at nearly the speed of light, passing through stars, clouds, and even your body without notice. Tonight, we explore the silent whispers of the Milky Way, carried by these invisible travelers. Cosmic rays originate from some of the most violent events in the galaxy: supernovae, pulsars, and distant active galaxies. Each particle carries energy and information from its birthplace, traveling across light years to reach every corner of the Milky Way. As they pass through gas clouds, they can trigger chemical reactions, ionize atoms, and subtly influence the conditions for star formation. Even in their invisibility, they leave traces that shape the evolution of the galaxy. The interstellar magnetic field guides these particles, twisting and spiraling their paths. They rarely move in straight lines, instead navigating a maze of invisible currents. Some collide with interstellar gas, producing showers of secondary particles that ripple through the galaxy. In this way, cosmic rays serve as messengers, connecting distant regions and silently recording the history of high-energy events. Even your own solar system is bathed in these particles. Trillions pass through the Earth every second, mostly unnoticed, yet some may affect planetary atmospheres and contribute to subtle chemical processes. Cosmic rays are the galaxy's whispers, constant, silent, and far-reaching, threading the Milky Way together across space and time. The presence of cosmic rays also reveals the dynamic nature of the galaxy. They trace shock waves from supernovae, pulsar activity, and the movements of massive stars. By studying their energies and paths, astronomers uncover hidden structures, map magnetic fields, and probe regions otherwise invisible in ordinary light. Each particle is a tiny clue in the ongoing story of the Milky Way. As you drift alongside these invisible travelers, imagine streams of particles weaving through gas clouds, tracing paths guided by unseen forces and silently connecting distant corners of the galaxy. The Milky Way is alive not only in light, but in these subtle, high-energy whispers that traverse its spiral arms, halo, and disk. Tonight, cosmic rays remind us that the galaxy speaks in many languages, not just stars and nebulae, but in invisible rapid currents of energy that hum silently through the Milky Way, linking its past, present, and future in ways we can feel but rarely see. Far above and below the Milky Way's central plane lie mysterious structures that hum silently across the galaxy, the Fermi gamma-ray bubbles. Tonight, we drift near these enormous lobes of high-energy radiation, tens of thousands of light-years tall, remnants of events that shape the galaxy's heart, and echoes of cosmic forces long past. These bubbles were discovered relatively recently, stretching symmetrically above and below the galactic center. They emit gamma rays, the highest energy form of light, invisible to human eyes but detectable by specialized space telescopes. Their origin remains a subject of research. Some scientists suggest they formed during a burst of activity from Sagittarius A star, the supermassive black hole, when it may have briefly ignited as a quasar. Others propose that intense star formation in the core pushed gas and radiation outward, inflating these colossal lobes. Imagine drifting past these bubbles. From afar, they are ghostly, ethereal structures, extending silently through space, carrying energy far above the plane of the galaxy. They trace past violence, powerful outflows, winds, or eruptions, yet now hover quietly, a lingering memory of events that shaped the Milky Way billions of years ago. Within the bubbles, charged particles spiral along magnetic fields, creating interactions that emit gamma rays. These emissions illuminate the otherwise invisible structure of the galaxy, revealing energy flows that would remain undetected in ordinary light. The Fermi bubbles are a reminder that the galaxy's story extends beyond stars, dust, and visible gas, that energy travels in hidden currents, quietly shaping the cosmos. These gamma-ray lobes also influence the surrounding halo. They heat gas, redistribute material, and may even regulate future star formation in nearby regions. Though the bubbles appear distant and calm, Their presence speaks of the immense forces that can erupt from the galaxy's center, sending energy and matter streaming into the halo, leaving traces for astronomers to decode. As you drift near these invisible structures, picture the Milky Way's past erupting in quiet, high-energy echoes, the central black hole or starburst regions sending ripples of gamma radiation into the halo. They are the galaxy's memory, silently archiving events that would otherwise be lost in time. Tonight, the Fermi bubbles remind us that even in stillness, the Milky Way carries the echoes of its own history. Energy lingers, flowing silently through space, shaping the halo, influencing motion, and whispering stories of a galaxy that is alive, energetic, and ever-changing across billions of years. Tonight, we return to the region we call home, the Orion Spur, a quiet lane nestled between the Milky Way's larger Sagittarius and Perseus arms. While it may seem unremarkable compared to the galaxy's grand spirals, this calm neighborhood has provided the stability necessary for our solar system and life on Earth to thrive. The Orion Spur is relatively sparse. It contains fewer massive stars and experiences less frequent supernovae than the major arms, creating a gentler, cosmic environment. Here, our Sun orbits the galactic center at over 828,000 kilometers per hour, yet it is sheltered from the denser, more chaotic regions of the Milky Way. This quiet corridor allows planetary systems to remain stable over billions of years, providing the calm conditions for complex chemistry and life to emerge. Within the spur, stars move in harmony with the galaxy's rotation, drifting slowly in patterns dictated by spiral density waves. Molecular clouds float through the lane, some collapsing into new stars, others lying dormant. Interstellar dust carries organic molecules, seeding forming planets with the building blocks of life. Even in apparent emptiness, the Orion Spur is full of potential, quietly shaping the future of stars and planets. Our solar system resides near the co-rotation radius, where the rotation of the spiral arms matches the average motion of stars. This gentle alignment reduces the frequency of spiral arm crossings, shielding Earth from the more hazardous regions of the galaxy. It is a cosmic rhythm that has contributed to the long-term stability of life on our planet. The Orion Spur is also home to scattered clusters of stars, remnants of past star formation events, and occasional rogue stars that pass through, tracing unique orbits through the galactic plane. Each stellar neighbor carries a story, a record of the galaxy's dynamic past and the quiet motions that allow regions like this to remain habitable. As you drift gently through this neighborhood, imagine the Sun and its planets moving quietly along a stable path, surrounded by distant stars and the slow hum of the galactic disk. This calm lane is more than just a location. It is a haven within a vast, dynamic galaxy. Tonight, the Orion Spur reminds us that within the Milky Way's vastness, pockets of serenity exist. These quiet regions nurture stars, planets, and perhaps life itself, providing a gentle contrast to the turbulence and energy found elsewhere in the galaxy, and offering a cosmic home where we can exist and wonder at the universe around us. Tonight, we explore a concept that connects the vast Milky Way to the possibility of life, the galactic habitable zone. Just as Earth orbits within the Sun's Goldilocks zone, the Milky Way itself has regions where conditions are stable enough to allow planets, stars, and life to thrive. Tonight, we drift through this quiet band of potential across the galaxy. The galactic habitable zone lies between the galaxy's dense, chaotic inner core and the sparse, metal-poor outskirts. Too close to the center, and planets are exposed to intense radiation, supernovae, and gravitational turbulence. Too far out, and the scarcity of heavy elements makes the formation of rocky planets unlikely. Between these extremes, lies a broad, stable region where stars host planets enriched with the materials necessary for life: carbon, oxygen, iron, and other essential elements. Our solar system resides within this band, benefiting from moderate star density and chemical richness. The Orion Spur, a quiet lane between the Sagittarius and Perseus arms, provides safety from frequent supernovae while offering access to gas clouds and heavy elements recycled from past generations of stars. In this calm corridor, Earth formed, and life had the time to emerge and evolve over billions of years. The galactic habitable zone is not static. As stars orbit the Milky Way, they drift through spiral arms, encounter molecular clouds, and experience subtle gravitational tugs. These motions influence planetary system stability, occasionally nudging comets or triggering minor cosmic disturbances. Even so, the overall region remains conducive to life over long periods, balancing exposure to energetic events with access to chemical resources. Beyond individual stars, the distribution of elements across the galaxy shapes potential habitability. Stars in the inner disk tend to be richer in metals, while halo stars are often metal-poor, relics from earlier epochs. This chemical gradient ensures that certain zones, like the Orion Spur, are prime locations for forming planets capable of sustaining life. As you drift through this quiet region tonight, imagine the Milky Way as a living ecosystem. Spiral arms, molecular clouds, stellar nurseries, and quiet lanes like the Orion Spur together create a delicate balance. Life, if it emerges, depends not only on individual stars, but on the galaxy's structure, motion, and the gentle cycles of matter and energy that have persisted for billions of years. Tonight, the galactic habitable zone reminds us that the Milky Way is not uniform. Some regions are harsh and turbulent, others calm and nurturing. Our place within this cosmic balance is not random. It is a result of billions of years of motion, chemistry, and quiet orchestration, providing a haven for planets, life, and the endless wonder of existence. Tonight, we drift once more along the spiral arms of the Milky Way, not as static structures, but as living, moving patterns shaped by gravity, density waves, and the motion of billions of stars. These sweeping arms are the highways of the galaxy, guiding gas, stars, and planetary systems through a continuous dance of motion and creation. The spiral arms are not made of fixed stars. Instead, they are density waves, rippling through the galactic disk like traffic jams on a cosmic scale. As stars and molecular clouds enter these waves, gas is compressed, triggering bursts of star formation. Young, bright stars illuminate these regions in blues and silvers, forming the glowing curves we see from Earth. As stars age, they drift out of the arms, replaced by new generations, giving the impression of solid, continuous spirals, while the individual stars move freely. Within these arms, molecular clouds and stellar nurseries are constantly forming and dissolving. Gravity, turbulence, and magnetic fields interact to regulate star formation, while supernovae scatter heavy elements into surrounding gas. Each spiral arm is a living, evolving structure, simultaneously nurturing new stars and preserving the traces of older generations. The motion of stars within the arms is complex. Some stars orbit faster than the density waves, some slower, and a few even move in retrograde paths, relics of past galactic mergers. These motions reveal the galaxy's hidden architecture and the subtle influence of dark matter, which holds the disk together despite differences in orbital speeds. Even our solar system drifts through these patterns. Over millions of years, the sun moves in and out of the spiral arms, experiencing varying star densities and radiation levels. This gentle, periodic exposure may influence cometary orbits and the dynamics of the interstellar medium, subtly connecting Earth to the rhythms of the Milky Way. As you float along tonight, imagine the spiral arms flowing past, illuminated by newborn stars, threaded with molecular clouds and dust, and guided by invisible currents of gravity. The galaxy is alive, moving, and constantly reshaping itself, a vast, elegant pattern of creation and motion. Tonight, the spiral arms remind us that the Milky Way is not static. It is a dynamic, flowing system where stars, gas, and dust interact in a continuous rhythm, quietly orchestrated by gravity and unseen forces. As you drift within this cosmic motion, you are part of the galaxy's endless dance, traveling along the living currents of its spiral arms. Tonight, we drift far beyond the luminous spiral arms into the Milky Way's galactic halo, a vast, faint, and nearly invisible region surrounding the disk. Here lie the relics of ancient mergers, rogue stars, and globular clusters, silent witnesses to the galaxy's long and tumultuous history. The halo is a spherical structure, sparsely populated, stretching hundreds of thousands of light years from the center. Stars in this region are often metal poor, formed shortly after the Big Bang, long before the disk fully developed. These ancient stars drift in tilted, elongated orbits, remnants of smaller galaxies absorbed by the Milky Way over billions of years. Each orbit preserves a record of past collisions, silently telling the story of cosmic cannibalism that shaped our galaxy. Scattered throughout the halo are globular clusters, densely packed spheres of hundreds of thousands of stars. Many are older than 12 billion years, carrying the chemical signatures of the early universe. Their metal-poor compositions reveal the conditions of the galaxy's infancy, while their stable orbits allow astronomers to trace the gravitational influence of dark matter. These clusters are cosmic time capsules, quietly preserving the Milky Way's ancient history. The halo also contains stellar streams, ribbons of stars pulled from disrupted dwarf galaxies. These streams wrap around the galaxy in arcs and curves, subtle yet telling traces of past mergers. They are evidence that the Milky Way is a living system, continually shaped by interactions with its smaller companions, assimilating new stars while preserving the memory of their origins. Even in the sparsity of the halo, motion is constant. Rogue stars and ejected planetary systems drift along unique paths, sometimes reaching hypervelocity speeds, mapping the invisible gravitational scaffolding of the galaxy. Dark matter dominates this region, providing the mass necessary to bind the halo together and maintain the Milky Way's structure. As you drift through the halo tonight, imagine ancient stars tracing slow, deliberate arcs through space, globular clusters glowing faintly, and the traces of long-vanished dwarf galaxies stretched into streams. The Milky Way's halo is quiet, distant, and almost invisible, yet it is alive with history, motion, and hidden influence. Tonight, the halo reminds us that the Milky Way is more than its luminous disk. It is a living archive where the remnants of ancient mergers and long-forgotten stars drift silently, preserving the galaxy's memory and shaping the structure that continues to evolve around us. Tonight, we look outward, beyond our galaxy, to the approaching Andromeda galaxy, the Milky Way's massive neighbor on a slow, inevitable collision course. This distant spiral, over 2 million light-years away, drifts steadily toward us, setting the stage for a cosmic encounter billions of years in the making. Though it may seem frightening, the eventual collision will be slow and graceful, not a chaotic crash. Stars are separated by vast distances, so direct collisions will be rare. Instead, gravity will reshape both galaxies, stretching spiral arms, twisting disks, and forming long tidal tails of stars. The result will be a merger, creating a single, larger galaxy, a quiet transformation unfolding over billions of years. The impending encounter illustrates the dynamic nature of galaxies. Even seemingly stable spirals like the Milky Way are built from collisions, mergers, and assimilation. Satellite galaxies, stellar streams, and ancient halo stars all tell the story of past interactions. The Andromeda collision is the latest chapter in a cosmic narrative, billions of years in the making. Before the merger, stars within each galaxy continue their independent orbits, but tidal forces will begin to distort their paths as the galaxies approach. Dark matter halos surrounding each galaxy interact first, guiding the eventual shapes and structure of the resulting merged galaxy. Even the unseen components play a critical role in orchestrating this slow cosmic ballet. As the two spirals converge, gas clouds may compress, sparking bursts of star formation. New stellar nurseries will light up regions previously dark, adding fresh brilliance to the combined galaxy. Supermassive black holes at the cores may eventually spiral together, influencing the dynamics of surrounding stars and releasing energetic outflows, leaving behind subtle but lasting imprints. Imagine drifting silently through this approaching encounter, watching Andromeda rise slowly in the sky, tracing the invisible paths of billions of stars. Though the event is billions of years away, the gravity of this spiral neighbor is already shaping the outer halo and distant orbits of our Milky Way. Tonight, the fate of Andromeda reminds us that the galaxy is never static. Collisions, mergers, and reshaping events are part of its life story. The Milky Way is a dynamic system, continuously evolving, influenced by neighbors near and far, carrying the silent promise of transformation across cosmic time. Beyond stars and molecular clouds, the Milky Way harbors countless rogue planets, worlds that drift alone through the galaxy, untethered to any star. Tonight, we follow these silent wanderers, exploring their mysterious journeys and the quiet role they play in the galaxy's vast ecosystem. Rogue planets may be ejected from their original planetary systems, often due to gravitational interactions with massive planets, nearby stars, or the central black hole. Others may have formed independently in dense clouds of gas, never acquiring a host star. These solitary planets drift through the halo, disk, or interstellar medium, invisible in most wavelengths, yet numerous, perhaps billions, reside within the Milky Way. Despite their isolation, rogue planets are far from inert. Many carry internal heat, remnants from formation or radioactive decay, potentially sustaining subsurface oceans in frozen worlds. Some may host atmospheres, magnetic fields, or even the conditions for life in extreme forms. Drifting silently through the galaxy, they are reminders that worlds are not confined to stellar neighborhoods. Life's possibilities may extend far beyond familiar orbits. Rogue planets also trace the gravitational landscape of the Milky Way. Their paths reveal the influence of dark matter, stellar clusters, and galactic tides, providing clues to the invisible forces that shape the galaxy. Astronomers detect them indirectly through gravitational microlensing or occasional interactions with gas clouds, piecing together their hidden population over time. These wandering worlds highlight the dynamic nature of planetary systems. Stars are not solitary islands. Planets may be scattered, captured, or ejected over billions of years. Even the calm regions of the Milky Way's halo are populated with these silent travelers. Drifting past molecular clouds, stellar nurseries, and the faint glow of distant stars. As you drift alongside these rogue planets, imagine them gliding alone through the darkness, illuminated only by distant starlight or their faint internal heat. They are cosmic wanderers, carrying the history of their birth systems and the quiet memory of forces that shape the galaxy. Tonight, rogue planets remind us that the Milky Way is alive with motion and possibility. far beyond what we can see. Even in the darkness, creation and evolution continue, and solitary worlds drift silently through the spiral arms and halo, contributing to the galaxy's enduring story of change and quiet wonder. Tonight, we turn our attention to the binary stars of the Milky Way, pairs of stars bound together by gravity, orbiting a shared center of mass. These celestial partnerships are far more common than solitary stars, shaping the dynamics of the galaxy and occasionally producing dramatic cosmic events. Binary stars come in many forms. Some are wide binaries, with stars separated by thousands of astronomical units, drifting leisurely around each other in calm orbits. Others are close binaries, orbiting so tightly that their gravitational interactions influence each other's evolution. Some even exchange mass, where one star siphons material from its companion, altering its life cycle and sometimes creating exotic phenomena like X-ray binaries. These partnerships play a critical role in galactic chemistry. When a massive star in a binary explodes as a supernova, its companion may survive, enriched with heavy elements or altered in orbit. Some binaries eventually merge, forming rare and powerful explosions that seed the interstellar medium with heavy elements like gold, platinum, and uranium. In this way, binary stars contribute to the galaxy's ongoing cycle of matter and creation. Binary stars also influence the motion of nearby objects. Their gravitational pull can eject rogue stars or planets, reshaping local stellar neighborhoods. In dense regions like globular clusters, binaries interact dynamically with other stars, trading partners, scattering members, or even catalyzing collisions that produce luminous blue stragglers or exotic stellar remnants. Even our own sun may have had companions long ago, lost to gravitational interactions in the Milky Way's early disk. Today, the galaxy is filled with these stellar pairs, quietly orbiting each other, influencing nearby clouds and shaping the orbits of planetary systems. Their interactions, while invisible to casual observation, leave subtle imprints on the motion of stars and the structure of the disk. As you drift through the galaxy tonight, imagine these binary stars in their elegant gravitational dances, some spinning tightly, others meandering at a leisurely pace, their fates intertwined over millions or billions of years. Their quiet companionships are both stable and transformative, shaping the very material from which new stars and planets will form. Tonight, binary stars remind us that the Milky Way is not just a collection of individual stars, but a network of dynamic relationships where partnerships create, evolve, and sometimes end in violent yet beautiful ways, sustaining the ongoing rhythm and complexity of the galaxy. Tonight, we drift into the end stages of stellar life, exploring the Milky Way's population of white dwarfs, neutron stars, and black holes. These stellar remnants are the quiet echoes of stars long extinguished, holding clues to the galaxy's past and subtly shaping its future. White dwarfs are the remnants of stars like the Sun, compact cores left behind after outer layers are shed. Though no longer producing energy through fusion, they glow faintly with residual heat, slowly cooling over billions of years. Each white dwarf preserves the chemical fingerprint of its progenitor, telling astronomers the story of past stellar generations and the enrichment of the interstellar medium. Neutron stars are born from the violent death of massive stars in supernova explosions. These ultra-dense objects can spin hundreds of times per second, emitting beams of radiation as pulses. Their precise pulses act as cosmic clocks, measuring distances, mapping magnetic fields, and even detecting gravitational waves. Despite their small size, neutron stars wield immense gravitational influence, subtly shaping nearby orbits and occasionally interacting with companions in binary systems. Black holes, the ultimate stellar remnants, form when the most massive stars collapse completely. Though invisible directly, their gravity dominates nearby space, influencing the motion of stars, gas clouds, and sometimes entire clusters. In the galaxy's center, Sagittarius A star, a supermassive black hole, orchestrates the dance of stars in tight orbits, silently holding the Milky Way together. Smaller stellar mass black holes drift through the disk and halo, remnants of violent pasts, often alone but always powerful. These remnants are more than relics. They are active participants in the galaxy's evolution. Supernovae that create neutron stars and black holes scatter heavy elements, seeding future stars and planets. Gravitational interactions with remnants can eject stars or planets, creating rogue travelers that roam the halo or intergalactic space. Even in apparent stillness, these remnants continue to sculpt the Milky Way. As you drift silently tonight, imagine these ancient remnants scattered across the galaxy. Faint white dwarfs cooling in the disk, neutron stars pulsing their rhythms through the halo, and black holes bending space around them, all quietly preserving the story of stars that lived and died billions of years ago. Tonight, stellar remnants remind us that the Milky Way carries a memory of every star. Even in death, stars continue to influence, shape, and enrich the galaxy, leaving behind a quiet yet profound legacy that you are part of as you drift through this living, breathing spiral of light and shadow. Tonight, we drift towards some of the rarest and oldest stars in the Milky Way, the hyper-metal-poor stars. These faint, ancient suns carry the chemical signature of the early universe, offering a glimpse into the galaxy's first epochs and the processes that shaped everything we see today. Hypermetal-poor stars contain almost no elements heavier than helium. They likely formed shortly after the first supernovae, when the universe had not yet been enriched with metals from multiple generations of stars. Some of these stars reside in the halo, moving on wide, tilted orbits far from the disk, preserving a pristine record of the conditions that prevailed over 13 billion years ago. These stars act as cosmic fossils, allowing astronomers to study the early Milky Way. Their compositions reveal that the first generations of stars produced only modest amounts of heavy elements. By analyzing their spectra, scientists can trace the history of nucleosynthesis and understand how the galaxy gradually accumulated metals, enabling the formation of planets, moons, and ultimately, life. Hypermetal-poor stars are faint and often isolated, drifting silently in the galaxy's outskirts. Their orbits are unusual, sometimes retrograde or highly inclined, remnants of early mergers with dwarf galaxies. Each carries a story of cosmic assembly, showing how the Milky Way grew, not in isolation, but through the quiet assimilation of smaller stellar systems. Despite their age and rarity, these stars continue to illuminate the galaxy, subtly influencing gravitational dynamics and providing a chemical baseline for comparison with younger stellar populations. They remind us that the Milky Way is layered in time, with ancient relics interspersed among newer stars, all orbiting the center in a complex gravitational web. As you drift among these cosmic fossils, imagine tracing the universe's earliest chemical patterns, observing stars that predate the disk, and feeling the weight of cosmic history preserved in their faint light. Hypermetal-poor stars are the Milky Way's living memory, quietly linking the present to a time when the galaxy was still forming. Tonight, these ancient stars remind us that the Milky Way is not just a galaxy of light, dust, and motion. It is a time capsule, preserving the earliest chapters of cosmic history. waiting silently for us to observe, wonder, and understand the universe's long and intricate story. Tonight, we drift into the quiet process of planetary formation, exploring how stars give birth not only to themselves, but to entire systems of worlds. From collapsing molecular clouds to spinning protoplanetary disks, every planet carries the chemical legacy of the Milky Way and the generations of stars that preceded it. When a star ignites within a dense molecular cloud, leftover gas and dust form a rotating disk around it. Within this disk, particles collide and stick together, gradually building larger bodies, planetesimals, protoplanets, and eventually fully formed planets. The process is delicate, influenced by gravity, magnetic fields, and turbulence, yet it repeats across billions of years throughout the Milky Way, creating countless planetary systems. The composition of a protoplanetary disk is inherited from the parent molecular cloud. Dust grains enriched with heavy elements from previous stellar generations combine with gas to form planets with diverse chemistry. Rocky planets, gas giants, icy moons, and asteroids all emerge from this cosmic recycling, ensuring that new worlds carry the fingerprints of stars that lived and died long before. Not all planets remain in their original systems. Some are ejected as rogue planets, wandering alone through the galaxy. Others may migrate inward or outward within their systems, influenced by gravitational interactions or the density waves of spiral arms. Even in apparent stability, planetary systems are dynamic, shaped by the forces of the galaxy around them. This formation process also links directly to potential habitability. Regions of the Milky Way with moderate metal abundance, such as the Orion Spur, provide the ingredients necessary for rocky planets and complex chemistry. Dust grains carry water, carbon compounds, and organic molecules, seeding new worlds with a raw material for life. In this sense, every planet is a descendant of countless generations of stars, a living product of cosmic inheritance. As you drift through the galaxy tonight, imagine spinning disks of gas and dust condensing into new worlds, planets forming in silent orbits around newborn stars, and the Milky Way quietly nurturing the next generation of celestial systems. Each system is unique, yet all share a common ancestry in the stars and clouds that came before. Tonight, planetary formation reminds us that the Milky Way is not just a collection of stars. It is a living, evolving workshop where matter cycles, energy flows, and new worlds are continually born from the recycled elements of the galaxy's long and luminous history. Tonight, we drift back in time to the birth of our sun, imagining the crowded stellar nursery where it first formed. Long ago, the sun was not alone. It shared space with hundreds, perhaps thousands, of sibling stars, all born from the same molecular cloud. Tonight, we explore this vanished cluster and the scattered legacy of those lost siblings. Stars rarely form in isolation. Gravitationally bound clusters provide the environment for stars to emerge together. Within this dense stellar nursery, interactions between stars were frequent. Some were ejected early, wandering through the galaxy as rogue stars. Others remained, but over millions of years, tidal forces, spiral arm motions, and gravitational disturbances gradually dissolved the cluster, scattering the sun's siblings across the Milky Way. Today, these stellar siblings are dispersed, many lost to the vast disk, halo, and even the outskirts of the galaxy. Astronomers search for them by analyzing chemical compositions, ages, and motions, hoping to find stars that share the sun's distinctive fingerprints. Some candidates have emerged, hinting at the possibility that our solar system still has lost family drifting silently among billions of stars. The birth cluster also influenced the early solar system. Close encounters with neighboring stars may have shaped the orbits of comets, minor planets, and other bodies, subtly sculpting the architecture of the planetary system. Even the calm path of the Sun today reflects the gentle nudge of these early companions. Drifting through this imagined cluster, picture the dense clouds of gas and dust illuminated by newborn stars, with the Sun nestled among siblings that would eventually scatter across the galaxy. Some may now reside tens of thousands of light years away, invisible to the naked eye, yet their origins forever tied to ours. Tonight, the Sun's birth cluster reminds us that our solar system is not solitary. We are part of a larger cosmic family, born in a crowded nursery, shaped by interactions with stars long gone, and carried through the Milky Way's spiral arms. Even today, echoes of that ancient cluster ripple quietly through the motions of stars, connecting us to a vast, living galaxy. Tonight, we drift along the Milky Way's disk, feeling its subtle movements and hidden rhythms. While the galaxy may appear flat and stable from a distance, its disk is far from static. It wobbles, warps, and ripples, responding to gravitational tugs, dark matter, and the long history of mergers. Tonight, we explore this quiet, flowing motion that shapes the Milky Way's structure. The galactic disk is composed of stars, gas, and dust, layered in thin and thick components. Over millions of years, interactions with satellite galaxies, tidal forces, and dark matter clumps gently distort the disk, creating bends and warps. These ripples move slowly, like waves on a spinning sheet of stars, tracing the invisible currents of gravity that govern the galaxy. Our solar system participates in this motion. As the Sun orbits the galactic center, it bobs above and below the plane in a slow, wave-like pattern over tens of millions of years. This vertical oscillation, caused by the galaxy's mass distribution and dark matter, subtly affects the paths of comets, gas clouds, and interstellar material, shaping the environment in which the planets orbit. The disk's warp also provides clues about past interactions. Satellite galaxies, like the large and small Magellanic Clouds, tug on the Milky Way's outer edges, bending and stretching the disk. Dark matter concentrations exert invisible forces, creating asymmetries that ripple through the stellar populations. Even the faintest deviations in the disk's shape preserve the memory of the galaxy's dynamic history. This gentle wobble is part of the Milky Way's ongoing evolution. Spiral arms shift, star formation is influenced by density waves, and molecular clouds respond to subtle gravitational forces. The disk is alive with motion, a vast, slow-turning engine of creation and structure. As you drift with the galaxy tonight, imagine the disk bending subtly under unseen forces, the stars moving in quiet arcs, and the halo and spiral arms interacting in a slow, cosmic dance. This wobble reminds us that the Milky Way is not a rigid structure, but a living, responsive system, constantly shaped by motion, gravity, and time. Tonight, the galactic wobble invites you to feel the Milky Way's rhythm, subtle, patient, and ongoing. A silent pulse guiding the stars, clouds, and planetary systems through billions of years of cosmic evolution. Tonight, we drift further into the Milky Way, exploring the forces that stretch and reshape stars and clusters across the galaxy. Galactic tides, the immense gravitational pulls exerted by the Milky Way itself, quietly sculpt stellar streams, peel apart clusters, and preserve the memory of past mergers. Just as the Moon raises tides on Earth, the Milky Way's mass exerts gravitational forces on stars, star clusters, and dwarf galaxies. Over millions of years, these forces stretch and distort groups of stars, creating elongated streams that wrap around the galaxy. These stellar streams trace the paths of ancient systems that were absorbed, slowly unraveling under the Milky Way's influence. Some streams originate from dwarf galaxies torn apart during collisions. Their stars are scattered across the halo and disk, forming thin ribbons that can extend tens of thousands of light years. Other streams come from disrupted star clusters, gradually losing members as tidal forces stretch and disperse them. Each stream is a fossil record, a quiet echo of the galaxy's growth through accretion and merger events. Observing these streams allows astronomers to map the dark matter halo of the Milky Way. The paths of the stars respond to the galaxy's unseen mass, revealing the invisible gravitational scaffolding that holds the galaxy together. Stellar streams are thus both relics of past interactions and tools for understanding the present structure of the Milky Way. Even within the disk, tidal forces subtly influence the motions of stars and clusters. Orbits shift over time, stars are ejected into the halo, and molecular clouds may be nudged into star formation. The galaxy is never truly static. Its structure evolves in response to the slow, persistent tug of gravity. As you drift among these elongated streams tonight, imagine the faint stars tracing long arcs across the sky, the remnants of galaxies and clusters long gone, silently weaving the history of the Milky Way. These streams carry stories of formation, destruction, and quiet rebirth, stretching across the halo like cosmic threads. Tonight, galactic tides remind us that the Milky Way is alive with memory and motion. Even the stars that appear isolated are connected, shaped by gravity, and participants in a vast, ongoing dance that preserves the galaxy's history while continuously shaping its future. Tonight, we drift into the unseen realm that holds the Milky Way together, the dark matter halo. This vast, invisible structure envelops the galaxy, outweighing all the visible stars, gas, and dust combined, yet we cannot see it directly. Tonight, we explore the silent force that shapes the galaxy's rotation, structure, and evolution. Stars in the Milky Way orbit faster than expected at large distances from the center. Without an unseen source of gravity, the outer stars should fly off into space. This discrepancy led astronomers to discover dark matter, a mysterious substance that does not emit, absorb, or reflect light, yet exerts gravitational influence. The halo formed by this material extends far beyond the visible disk, encompassing stars, clusters, and satellite galaxies. The dark matter halo acts as the galaxy's gravitational backbone. It maintains the integrity of spiral arms, stabilizes stellar orbits, and guides the paths of globular clusters, rogue stars, and satellite galaxies. Even the motion of molecular clouds and tidal streams is subtly influenced by this invisible mass, shaping the Milky Way's overall architecture. Within the halo, remnants of ancient mergers and stellar streams drift, tracing the contours of dark matter. Their paths reveal the distribution of the unseen mass, providing astronomers with critical insights into the Milky Way's hidden structure. Each stream, each wandering star, acts as a probe, mapping the invisible scaffolding of our galaxy. Dark matter also plays a role in the galaxy's growth and evolution. Satellite galaxies are captured and assimilated into the Milky Way under the influence of the halo's gravity. Gas streams feeding the disk are guided by its pull, contributing to star formation and the ongoing recycling of matter. Without this invisible mass, the Milky Way would be fragile, unable to maintain its elegant spiral form. As you drift through the halo tonight, imagine a vast, unseen sea surrounding the Milky Way, quietly orchestrating motion, shaping orbits, and preserving the structure of the galaxy. Invisible yet essential, dark matter is the silent architect of the Milky Way's grandeur. Tonight, the dark matter halo reminds us that what we cannot see often shapes everything we can. The Milky Way's beauty, motion, and stability rely on this hidden force, silently supporting the stars, planets, and cosmic phenomena that light up the galaxy around us. Tonight, we drift toward the center of the Milky Way, where an enormous supermassive black hole lies in wait. Sagittarius, a star. Though invisible directly, its presence dominates the motions of stars, gas clouds, and stellar remnants in the galactic core, orchestrating a slow, silent dance at the heart of our galaxy. Sagittarius. A star weighs more than 4 million times the mass of the Sun, yet it occupies a space smaller than Mercury's orbit. Its gravity binds nearby stars into tight, rapid orbits, allowing astronomers to trace its mass indirectly by observing their motions. Occasionally, gas and dust spiral inward, flaring in X-rays as they near the event horizon, offering glimpses of the galaxy's most extreme environment. This black hole has a complex past. Evidence suggests it may have once been far more active, igniting as a quasar and sending jets of radiation and energetic particles into the galaxy. The Fermi gamma ray bubbles above and below the disk may be remnants of such ancient activity, silently echoing the black hole's earlier outbursts. Sagittarius, a star, also subtly influences star formation in the galactic center. Its gravity helps sculpt the central bulge, a dense peanut-shaped structure of stars and gas, and guides the motion of stars within the inner parsecs. Even the disk and halo feel its pull, though indirectly, as the black hole sits at the gravitational core of the Milky Way. Stars near the black hole live on the edge of extreme physics. Some are flung outward as hypervelocity stars, ejected by close encounters with the black hole's immense gravity. Others orbit in tight, rapid loops, tracing paths shaped by the curvature of space-time itself. Each star in the central cluster carries the imprint of Sagittarius, a star, silently narrating the story of the galaxy's heart. As you drift near this central region tonight, imagine a dense, dynamic environment where stars whip around unseen gravity, gas spirals inward in quiet flares, and the black hole holds the core together. The galactic center is both a cauldron of energy and a masterful conductor of stellar motion. Tonight, Sagittarius A star reminds us that at the heart of the Milky Way lies a silent, powerful force, invisible yet dominant, orchestrating the galaxy's structure, shaping its evolution, and holding together the billions of stars that swirl around it in a cosmic dance. Tonight, we drift through the stellar nurseries of the Milky Way, where clouds of gas and dust collapse to ignite new stars. These regions are the galaxy's cradles of creation, glowing with the first light of newborn suns and quietly shaping the spiral arms we admire from Earth. Stellar nurseries form within dense molecular clouds, compressed by gravity, turbulence, and sometimes the shock waves of nearby supernova. As gas collapses, it heats, spins, and flattens into a protostar surrounded by a rotating disk. Over thousands to millions of years, nuclear fusion ignites in the core, and a new star begins to shine, lighting up the surrounding clouds in brilliant blues, silvers, and reds. These regions are not only spectacular, but essential to the galaxy's life cycle. Stars formed in nurseries will eventually enrich the interstellar medium with heavy elements through stellar winds and supernova explosions. This recycled material seeds future generations of stars and planets, ensuring the continuity of creation across billions of years. Stellar nurseries are dynamic and chaotic. Gas flows in turbulent patterns, magnetic fields twist and align dust, and ultraviolet radiation from young stars carves cavities in surrounding clouds. Each nursery is a miniature ecosystem where matter cycles between birth and destruction, light emerges from darkness, and the galaxy quietly renews itself. Even our sun was born in such a nursery, along with hundreds of sibling stars, forming in a dense, clustered environment before drifting into the calm of the Orion Spur. These regions demonstrate that creation often begins in hidden, shadowed spaces where potential is abundant, yet invisible to the naked eye. As you drift through these nurseries tonight, imagine glowing clouds of gas, spinning disks of material condensing into new stars, and the gentle push and pull of gravity orchestrating formation. Light emerges from darkness, and the Milky Way continues its cycle of creation, generation after generation. Tonight, stellar nurseries remind us that the galaxy is not static. Even in apparent stillness, matter collapses, stars ignite, and light is born, quietly illuminating the Milky Way while sustaining the endless rhythm of cosmic life. Tonight, we pause to reflect on the Milky Way as a living, evolving system, a galaxy not fixed in time, but constantly reshaped by motion, gravity, and the cycles of creation and destruction. From its spiral arms to its halo, from newborn stars to ancient remnants, the Milky Way is a dynamic, interconnected network, and you are a part of it. Every star, every cloud of gas and dust, every globular cluster and rogue planet contributes to the galaxy's story. Stars are born, live, and die. Gas is recycled. Matter flows through the disk and halo. Magnetic fields and dark matter silently guide motion. Even invisible forces shape the Milky Way, sculpting its structure over billions of years while preserving the record of its history. Your solar system drifts within the Orion Spur, a quiet lane between the galaxy's major arms, orbiting the center at incredible speed, yet in gentle harmony. Every atom in your body traces its origin to stellar explosions, recycled through clouds and condensed into planets, showing that life itself is connected to this vast, luminous spiral. You are not a passive observer. You are part of the Milky Way's ongoing rhythm, moving in concert with its countless stars. The galaxy is alive in many ways. Molecular clouds cradle newborn stars. Stellar nurseries ignite new light. Supernova shockwaves stir the interstellar medium, and dark matter provides invisible support. Pulsars tick like cosmic clocks. Gamma ray bubbles echo past energy, and stellar streams preserve ancient mergers. Every corner of the Milky Way hums with motion, memory, and potential. Even as you rest tonight, the galaxy continues its silent, patient work. Stars orbit, clouds collapse, black holes hold their dominion, and matter cycles endlessly. The Milky Way is not static. It breathes, evolves, and renews itself, and you drift within this vast, interconnected system, a witness to its history and a participant in its story. Tonight, as you imagine the galaxy unfolding around you, remember that you are part of something far larger than Earth, far grander than any single star. The Milky Way is alive, a dynamic, living galaxy, and in its quiet, patient turns, it carries you along, a small but essential thread in its luminous, timeless tapestry. As our journey through the Milky Way comes to a close, take a moment to feel the galaxy turning around you. From the spiral arms to the halo, from newborn stars to ancient remnants, you've floated through cosmic history, witnessed the birth and death of stars, and glimpsed the unseen forces that hold our galaxy together. The Milky Way is alive. It rotates, breathes, and evolves across billions of years, quietly shaping stars, planetary systems, and even the possibility of life. And tonight, you've been part of that rhythm, a silent observer, drifting alongside the sun, floating through stellar nurseries, and tracing the paths of ancient stars and ghostly remnants. Remember that the atoms in your body, the oxygen you breathe, and the iron in your blood were forged in stars long gone, scattered across space, and recycled into the Milky Way's living cycle. You are not separate from the galaxy. You are an intrinsic part of its story, a small but luminous thread in its vast, interconnected tapestry. If tonight's journey has helped you relax, sparked your curiosity, or given you a quiet space to drift, consider liking and subscribing to Sleepy Universe Zone. It helps more explorers like you find their way here, one gentle orbit at a time. Now, let the stars dim behind your thoughts. Feel the galaxy turning, stars forming, and silent orbits continuing as you float within this vast cosmic home. Rest, breathe, and dream softly. Good night.